Okay, hey, we're going to be dealing with adding and subtracting polynomials. All right, so first thing we need to do, you need to go through and define these terms to the best of your ability. Now, ones you already know off of page 206, I want you to go through and do your best to define those terms. Now, there's a couple more, but try to get them all up there.
Would term work in place of the word nomial?
Okay, what's a monomial? One? Well, let's actually start down here with polynomial. What's polynomial?
More than one.
Okay, it means multiple terms. Okay, it's an expression with multiple terms. Okay, an example of a polynomial may be like 4x squared plus 2x plus 7. That's a polynomial. That's multiple terms. A monomial means mono means one term. So maybe just 4x squared. That's one term. It's important to note that terms are separated by addition and subtraction signs. So when you're looking to see if how many terms there are, you've got to look in between addition and subtraction signs. Okay? Not multiplication signs. So there's two different pieces here, but they're all the same term. Okay? The degree of the monomial. Degree is the highest power that it's raised to. So this is a second degree. And we have a special name for a second degree. We call it a?
Square root.
Almost. Quadratic. Okay? So we'll go through these in a different setting here in a minute. A binomial means there are how many terms? Two. Okay, so maybe like 4x cubed minus 2x squared. That's two terms. What would the degree of this one be?
3 and 2.
It would just be 3. We look at the highest degree.
Oh.
Hey, Jonathan, close it, please. Okay, trinomial. This actually is a trinomial. Okay?
Isn't a
right.
polynomial anything greater than 3?
Polynomial is anything. Okay? If we have more than 3, we just call it a polynomial. Okay, but a binomial is also a polynomial. It's kind of a special. It's that generic term for all of them. Okay, degree of a polynomial. Okay, or we always look at the highest degree. Standard form means you are listing things in order by degree. So if I gave you, for instance, 4x plus 2x squared minus 8 plus 7x cubed minus x to the 4th, to put that in standard form, I've got to look at the highest power. What's the highest power? The 4. So this piece, along with the negative, goes first. What's the next highest? 3. So we move that now. And then that. Notice the symbol goes with it. And then that. There isn't a symbol. It's always plus. And then that. Okay, you're ordering your powers from greatest to least. Leading coefficient is the term that's attached to the highest power. Okay? So Logan, what's the highest power in this? X to the 4th. And what's the term out in front of that? Yeah, in this case it's -1. So the leading coefficient is -1. It's the one that's attached to the highest power. So what's the leading coefficient of this one up here? X, leading coefficient. 4. Okay. Jonathan, leading coefficient of this one. Give it a shot. You have 3 choices. You don't know? Are you going to participate in class? What's that? All right, we'll talk about it here in a minute. Okay, I want you guys to go ahead and take a look at the next page of your student journal, page 203. Okay? Huh? Oh, I'm sorry, page 207. Okay? You guys, do you have room on the bottom of page 206 to do some notes? Actually, let's do the notes on the bottom of page 206. I think that'll be a little better for you. Let's go ahead and talk about some classifications real quick.
Yay, classification.
All right, so if we are classifying something by degree, yep, we're classifying something by degree. If we say
x to the first, maybe, or x to the 0.
let's say I just have x. Actually, let's not even use x. Let's say I have the number 5. Okay?
0.
5 has a degree of 0. Okay, and I'm actually going to spell it out. Otherwise, you get confused maybe with all the numbers. 0. Okay, let's say I have x plus 7. That has a degree of 1. Okay? It's this one right here that we're looking at. Let's say I have x squared minus 4x plus 8.
Squared still.
My degree here is 2. Okay? And let's say I have like x cubed. Let's just say I have x cubed. That is a degree 3. Now these have special names right here. This right here is called a constant. That is its special name. A 0 degree is called constant. This one is called, what type of line is that?
Flat. Infinite.
It's linear. I guess I kind of gave it away with the question. It's linear. This one is called quadratic. And this one is cubic. All right, if we go above 4th degree, so let's say I have x to the 4th plus 2. That's a 4th degree. Okay, that actually is called a quartic. Quartic. Sorry, if we go above 4th degree, however, we're just going to call it whatever degree you're on. So if I go x to the 5th, we're just going to call that a 5th degree. We're not going to give it a special name.
Oh, so quartic is the highest special name.
That's the highest special name we're going to cover.
Everybody else is beneath it.
Okay, so you classify by degree. You also classify by the number of terms.
It could be pentic, actually.
Yeah, it could. But we're not going to classify anything else then. Okay, number of terms.
It could even be quintic.
How many terms right here?
1.
1. So we call it a
Monomial.
monomial.
Binomial.
How many terms?
2.
2.
Binomial.
2 meaning, or bi meaning 2. How many terms here?
3.
3 terms, so trinomial. Notice they all end with the nomial there. Okay, how about this one?
1 term.
1, this is a
Monomial.
monomial. How many terms?
2.
1, 2. How many terms? 1, so we call it a monomial. You know what? Hey, since we have a little extra room here, I'm going to get rid of this monomial. We're going to make this into a polynomial with 4 terms. Okay? So how would I make x to the 5th into a polynomial with 4 terms? Actually, why don't you guys do that on your paper? Make x to the 5th into a polynomial with 4 terms right now. All right. Help me out here. What do we got? Gunnar, take those out, please. I know, man. Both of them. Hey. Oh, you got them? Okay. Do you get tired of me telling you that? Yeah. I get tired of saying it if it makes you feel any better. All right. Yeah.
I got x to the 5th plus 3 plus 2x plus 0.0001.
I'm just going to put that. Okay. All right. There we go. Anything with 4 terms there would work, except for that's only 3 terms. Does anyone know why that's only 3 terms? Really?
Oh, yeah.
Not because the x's will go together. X? Yeah, because these two will go together. So what could I put at the end here to make this 4 terms? Since these two will go together, this would actually be a trinomial.
Y or D.
Yeah, let's put a y right there. Now it's 4 terms. Okay? So if you can simplify it in any way, you have to do that first and then classify it. Okay, any questions there? All right. Hey, page 208, Student Journal. I want you to go ahead and work. Actually, 207. Bottom page 207 is where it starts. I want you to work through that page. You work together on it.
Okay.
And go. Okay, here are solutions for 1 through 8. Number 1, first degree, which we call a. These are all monomials, right? Okay, so I guess we wouldn't have to call them on. First degree, 0 degree. First degree isn't a constant, no. A constant would be just a number, a 0 degree. Okay, so this would be a constant. Okay, first degree we actually call linear, but first degree, 0 degree, this is 3rd degree. Why is this 3rd degree? Yeah, that's kind of weird, right? Because you got to the first, and to the first, so we have a total of 3. 3rd degree. Okay, we got to add them up. This is 3rd degree as well. This one is 2, 3, and 1 is
4.
6th degree.
Oh, yeah. Whoops.
Kind of something we hadn't seen before. This is 1 and 3 is
4.
4th degree. And this one is 0 degree. All right. Any questions there? Yeah.
So the m and the n on number 7.
Yep.
Since the n has the 3, then you just put the 1 because it's equal to m, and then you just add them.
Yep. If there's not a power, it's 1, and then we add them up. Yeah. Okay. Any other questions? Okay. Numbers 9 through 12. Off you go. Next page, page 208. Okay, here we go. Hey, number 9. Degree is 2. Leading coefficient is 3. Trinomial. In standard form, you've got to have 3x squared plus x plus 5. Number 10. Root 5y. It's a first degree. Leading coefficient is root 5 and monomial. Notice the number root 5, it's still a number. Okay, just drop that variable to get our leading coefficient. Number 11, 6x to the 8th plus 3x to the 5th, 8th degree, leading coefficient 6, and it's binomial. And the last one, number 12, f to the 4th plus f squared minus 2f. It is a 4th degree, also called a quartic, you can call it. And leading coefficient is 1, it's a trinomial. You guys, if you called this one in terms of degree, what could we have called it? What's the other name? Linear. And this one is quadratic. Okay, go with either of those. All right. Any questions there? Okay, I want you to try 13 and 15, please. Number 13 and 15. Okay, so when we're adding up, we're just adding our like terms. Okay, so here the parentheses don't mean anything because there's nothing outside of them. If you had, say, like a 2 out here, you'd have to distribute that in. However, they don't show the 2. There's nothing out there, so we can drop the parentheses. Okay, earbuds out. I know. Hey guys, let me talk to you about earbuds. You guys drop your parentheses. We got negative 4x, 6x, minus 14. Negative 4x and 6x is 2x. 9 and negative 14 is negative 5. Okay? Tell your neighbor what you got on number 15.
I got 9x plus 1 as the end result.
Nice, dude. Man. Hey, one thing that's helpful for some is to actually like circle the like terms. So x squared and negative x squared are like, that becomes 0. 3x and 6x are like. I put a rectangle around them, that gives me 9x. 5 and negative 4 are the last two pieces. Those two give me 1. Okay. Adding shouldn't be terribly difficult. Okay, subtracting is where we kind of make the mistake. So I want you to try number 17 and 18, or excuse me, 17 and 19, and we'll call it good there. Give those two a go. Guys, the subtraction ones don't have to be difficult, but there's one little piece that makes a mess, kind of messes up students. This negative out here is like having a negative 1. So anytime I see a negative outside parentheses, I circle it, I put the 1 in there. That just reminds me that really what I'm doing is distributing negative 1. Or maybe an easier way to think about it is when you see a minus outside of parentheses, just flip all your signs on the inside. So this was positive 3, it now becomes negative 3. This was negative 6, it now becomes positive 6. So really you have g minus 4 in the front, nothing changes up there, and then in the back you have minus 3g plus 6. The g's go together, that gives me negative 2g, and the negative 4 and positive 6 go together to give me a positive 2. Okay. How many got that? Cool. Okay. So if I'm flipping the signs in here, this becomes plus, this becomes positive, this becomes positive, and that becomes positive. And we put them together. X squared, 3x squared, it's 2x squared. We have our x, and we have right there. Okay. Any questions?